And I'm just going to run it from Rider's play button. But I mean, look at those numbers. That is just nuts. I mean, completely bananas, right? So, I mean, 3 to 8 to 14 to 19 to 30. I mean, just crazy. I mean, the sheer like and raw potential of this in a scalable system is nuts. I mean, so it consumed pretty much 5.6 million messages in 1 second, which is just completely bananas. Hey, how's it going, everybody? Welcome back to another RabbitMQ video in .NET. This one is specifically going to be about the performance of the RabbitMQ streams library for .NET. And if I scroll up on my console, you can see, and mind you, these are in millions, this absolutely insane performance. I mean, it goes from 20,816,072 messages consumed. Next second, it then is up to 25,600,000 messages. So it consumed pretty much 5.6 million messages in 1 second, which is just completely bananas. Before we get into the code here, I do want to shout out somebody on my Discord that helped me out with this, Gabriel, if I'm pronouncing your name correctly. Thank you for helping me with this and walking me through and providing some of the code samples. Really appreciate it, and it's definitely helped me to get the performance numbers that I should have been seeing in the first place. So if you went back, anyone who's watching, if you go back, I had a video where I initially tested the streams protocol, but I didn't set up correctly, so I was only seeing like 200,000-ish messages throughput per second, which is like super low compared to this. So yeah, let's get into this real fast. So let's go to my RabbitMQ, just localhost. So I just have a stream created called engine. It's pretty much just default out of the box configuration. So again, the queue type is a stream. I have 25.6 million records, messages in there, and the messages specifically, just so I can show you the data, is just my name with an exclamation mark in bytes. So nothing too crazy, no complex object. We're going to get to that later in the video, but I want to show you the throughput just with a really basic this short byte array or a small byte array. So that is the setup in RabbitMQ. So I'm going to go ahead and actually just run this right now. And to get the most performance, I'm going to just open a terminal here, and then I'm just going to do, I'm going to run it in the release build, so it's the fastest. And then you can see the console output just completely spiking like that. So it's already done. It's going to keep going. Okay. So we start out at 3,671,968 messages consumed in the first second. Second. So in another second, we're already up to 9.5 million. And then 15 million. Then 21. So we're like seeing 5 to 6 million messages consumed per second, which is just insane. I mean, completely insane. So if we go to my consumer, let me terminate this console. I just can't get over how quick this is, this binary protocol. I tried to structure it like how I had other consumers registered for just classic queues. So if I go to one of my historical car engine data consumers, it's just a background service, and then really the way I have it set up is I have a method that returns a task for building my RabbitMQ connection, which just establishes the makes the connection and the channel, and it does all just the declares and bindings. And then I just use the continuation task to run the actual to create the event handler and then run my consumer. So I wanted to structure it like this because this is how I've done it for just regular classic queues. And it's nice too because so I have this consumer stopped task completion source that basically will get set upon cancellation of the cancellation of the token. So I registered a callback, so it'll set that, and then it'll return that task. You can do it other ways. You can just wrap this in a while for, with the stopping token dot, is canceled or something like that. So there's a number of ways to do this, but in .NET, I found that background services can mostly be used to make a just continuous consumer. So I wanted it to be similar to that structure. So I essentially did the same thing with my build RabbitMQ connection method, but instead now I'm using the RabbitMQ stream client, and I'm specifically using the reliable methods. And so I go ahead and build the stream, make it if it doesn't exist in my RabbitMQ connection. Then for my continuation task, I'm just having a consumer just increment this count variable that is then going to be written from the console every second, which this here was a really neat idea to do. So thanks for, again, showing me some of that code from the RabbitMQ performance test. So that was a really neat idea. So I ended up using the same thing really for running that background task and outputting it to the console every second. So again, thank you. I appreciate the help on that. And then for my incrementing the count, I'm just going to then just await a task completed, which this message handler, the delegate here has a signature of string, raw consumer, message context, and message, and then it's going to return a task. So that's why I just am just going to await this task, completed task. But yeah, I'm not actually using any of the data from the consumer. I'm literally just incrementing this count just to see just the raw, like, here's the throughput number for the consumer. So you saw on the console what it is in release, and I'm just going to actually run that again. So let's go ahead and open a new terminal, and let's go and run this again. So again, you're going to see that console immediately output with just absolutely insane throughput numbers. Again, like 5 or 6 million messages a second. On my specific endpoints, to populate my stream, I just have this endpoint here that posts about 1 million messages to the queue or to the stream. It does it in about a second. So you can see it's going to add to that number. And you can actually see when I hit the endpoint, you can see that this console is going to increase because it's instantly going to consume those messages that I'm publishing to the stream. So now let's refresh RabbitMQ. There's usually a little bit of delay here. So yeah, a little bit of delay on the UI side of things. But yeah, we should be at 34.6. Now we should be at 35.6. So I'm just going to let the UI just refresh there. So 35.6. So my consumer is going to be running, obviously picking that up. But for the actual producer settings for this, it's similar to the consumer. I have a RabbitMQ service that I'm calling from my endpoint. It's basically going to use that same methods through the RabbitMQ streams reliable library. And then here's where it gets a little funny. Is that, here, let me move this over. This producer config, these values are really interesting to mess with. So messages buffer size says that it's the number of messages sent for each frame send. High values can increase the throughput, low values can reduce the message latency, and the default value is 100. Max in flight is another interesting number here, but both of these I've had to mess with whenever I've changed the message contents. So however big my byte array is going to affect, okay, how many messages or how many basically, packets am I sending over my connection is the way I gather it. Because it says each frame send. So I don't know if it's referring to like the frame on the TCP connection or if it's, I don't know what, or if it's the frame for the on the actual message itself to RabbitMQ. But either way, this here, I've noticed when I've changed how many bytes are in my array, I've had to kind of mess with these numbers as well, because if they're too low, then I'm just going to get an error to say that, hey, like this, it's exceeding that. So that's a little bit something I've had to mess with too. I've also had to mess with how I'm sending these in batches. So you can see here that the send takes in a list of messages, and I just basically am adding messages to a list, and then I'm adding that list of messages to a total messages list, so that way I can iterate through the total messages and then send them in batches. It seems like whenever I mess with this, it actually affects my consumer rate too. When I wasn't using the batch send and was just sending one at a time, my consumer rate was way lower compared to when I was doing it this way. So again, this is something that I've had to kind of go back and forth on and mess with, but here's the configuration I have for that. So, but you can see, like, when I add it, I mean, it takes no time at all. I mean, that's like less than a second to send 1 million messages to the queue or to the stream. So just insane performance. Again, I just want to rerun this again. I'm just going to terminate this, and I'm just going to run it from Rider's play button. But I mean, look at those numbers. That is just nuts. I mean, completely bananas, right? So I mean, 3 to 8 to 14 to 19 to 30. I mean, just crazy. I mean, the sheer like and raw potential of this in a scalable system is nuts. I mean, I just don't see more like documented use of this. I mean, it's so like the flexibility that you get with RabbitMQ for using, like, having the ability to use a stream or a queue with exchanges. I mean, there's just a ton of flexibility there, but also the fact that you can get these kind of throughput numbers in a resilient way, right? Because my stream, it's just going to be based on my whatever my offset I'm specifying. So if I need a specific thing in time, I can specify the offset and I can get these messages. So the messages are here. Obviously, I'm not working in a RabbitMQ cluster, right? This is just running on my local host. But if this was a distributed environment with RabbitMQ and I was getting this kind of throughput, I mean, that's just nuts. I mean, this is really something that I really want to do a lot more research into and to figure out, like, just how to take the full, like, how to leverage this fully, because this is just completely insane to me. Just seeing 5 million to 6 million messages a second. I mean, it's crazy, right? Unless I'm just like not thinking about it, right? Like, that's nuts. That's super good. Really, really good. So there was one thing that I want to test with. So I'm actually going to delete my stream because I want to send like a more complex message, right? So I'm going to delete this queue. So that's gone. So I want to go back to my producer, and I want to change the message here to be like, I want to change it to see if I can do an object, which I might have to. Let's make a new class like at the bottom here, and we'll just say, we'll call it Steven. We'll call it car data. We can think about cars as having, maybe a make. We'll do a make, model, and we'll just do horsepower. So really basic information about a car. But I want to here, I don't know what this is going to do to my memory here, but I'm just going to make a new car this way. And I'm going to say make is going to be we'll do Subaru. Model is going to be WRX, and horsepower, what do they get, like 260? I think so. Okay, so that's going to be my object. So now what I want to do is I'm just going to comment out my previous edition of that. I need to get data into what it would be in a byte array. So what I'm going to do, message.add, we're going to say new message, and I want to add my data. But data itself is going to give me an error because it's not an array of bytes. Let's see if this, can I say get, I might have to do system.encoding. I think it's encoding, right? UTF-8 dot get bytes, and then I think I can pass my object in. Now, what is it telling me that? Cannot resolve candidates are, so I can pass in a read-only sequence of characters, a string. I might have to data, maybe JSON serializer serialize data. Okay, I serialize it to be a JSON string, and then I'm getting the bytes from that. Let's see what happens here. And let's see what happens with the throughput. Again, just a really basic object that is going to have the same data every time, but I just want to see how much it affects the throughput. I may have to mess with these again because I think it's going to exceed that packet size. But let's go ahead and just see what happens. Oh. Which, actually, let me not debug that. Let me just run this so we're not running with the debug flag. So obviously you can see that we have 0 for the consumer because we're not, the queue or the stream doesn't have anything in there. Let me go ahead and hit populate stream and let's see what happens. Which we should see. Okay. Cool. So you can see it takes a little bit, well, okay, maybe not. It doesn't take much longer at all. It takes maybe like a hair longer, like not much time, not much longer at all. I'm just going to get it up to enough where we can actually see some throughput rates here when my consumer kicks on. All right. And I'm going to restart this, stop and rerun. I got to stop it because it's going to run the task. That's the one thing about when you just have a continuing background task, it messes up your stopping or your terminating of the. That's just nuts. Look at the throughput, even with the more complex objects. I mean, I haven't even tweaked these numbers, which I'm sure I could mess with the batching, but I mean, I'm seeing like 4 million a second. Still, 14 million. It goes from 10.9 to 14. I mean, 3.1. I mean, 6.7 to 10.9. I mean, just crazy. I mean, how many, like, you can send so much data through this. I mean, that's just the coolest thing ever. So, again, my stream, I can add however many consumers I want to this because it's a stream. Specify offsets. I mean, just really, really cool stuff. I think I know at one point I was, well, let me actually go to my code because I know I was messing with, yeah, I set up a method here that I could pass in the number of days that I want to start from in my stream. And I think that I had done a timestamp, so it would like look at the number of days and like go back based on the timestamp. It was pretty neat, like super powerful. Like if you have ever worked with Kafka or any kind of other like log streaming type thing, you can get comparable functionality, it seems, with RabbitMQ streams. I'd be curious to know like what the adoption rate is of RabbitMQ streams versus a tool like Kafka. Um, because I always see those compared and contrasted, but I never see streams compared to Kafka, like Kafka streams. And to me, like this is such a nice solution and it just works really well. And again, you get like the best of both worlds with queues, but also streams. But even if you don't want to go through the trouble of like exposing the port 5552 and enabling the plugin to activate the stream functionality, you can still use the RabbitMQ client and then just specify the queue type, which would be here, to be stream, and then you can just use your client consumer, like if you had the one that would typically talk to like a classic or quorum queue. So again, super powerful, and you can like, I feel like with this, like it sets it up for you, but you can just add so much functionality with your code to connect to this that to me it's just, this is so nice, right? Like I would definitely recommend using this because it's just super nice. And I mean, you saw the numbers on here. I mean, it's just crazy. So anyway, yeah, I'm excited about this because I think this has so much potential use case in system design, and definitely going to be seeing more content around RabbitMQ. We've done a lot already on this channel, but I have a lot of ideas that I want to try out, and we'll see where we go from here. So thank you all for watching. I'll see you in the next one.